Hello, this is a training video on how to create a tool by duplicating another tool in Fusion 360 for your milling library. This will give you the flexibility to create tools if they're not in your existing tool library. First, you have to switch to the workspace manufacturer. Once you're in the manufacturer workspace, you're going to select Manage. Select the down arrow on Manage and select Tool Library. Okay, so you should have your tool library pop up at this point. It may not be displaying exactly what I have here. So if it isn't, we're going to expand local, make sure it's checked, and then we'll have a series of libraries within the local folder. And you should have created in the prior video this TCOS library and copied some tools from the two Titan libraries that I made available. If you haven't done that, you need to go back and watch the prior video to get it set up. And when you select on TCOS, you should have this arrangement of tools. Tool 1 is from our water jet exercise, so it's not necessary for the following tutorial, but all the rest of these tools are. We have some duplicate tool numbers, but if you notice right now, these are lathe tools that have been copied over. So that's fine, they're not going to be used on the same machine. Alright, so go back and watch that video if you haven't set this up. And also it's a good idea to have watched all the lecture material on cutting tools so that the nomenclature for the numbers that we're going to be punching in here makes a little more sense. So make sure you've reviewed that as well. Okay, here we go. We're going to copy this 16th end mill, and we need an 1/8 inch end mill according to our assignment. You're going to right click on the tool 5 from the Titan library, and we're going to copy that tool again. And then we're going to right click in the space and select paste. So we now have two tool 5s that are 16th end mill. We're going to edit the second the duplicate. And if it doesn't pop up with this window by default, go ahead and pick on the General tab. It may pop up with a different default if you've been doing work in the tool library. And the first thing we're going to do is we're going to change all the information. Now, this is a copied tool. Titan has an agreement with Kennametal, so he makes money off advertising them. So generally this stuff would not be filled out for you unless you have gotten a library from somebody else. But it is very convenient to have this much information because you can go straight from the product idea to their website and even order the tools. So typically you size up a job in the beginning, you go review the drawing and make a list of tools you need to program before you even start programming. And that's well within the scope of the expectations of a CAD/CAM programmers, that you can do that planning and do the research to find the appropriate tools. We're going to build off of this so you can find the function of where all the data is to build a tool. And we're using an existing holder that's also Kennametal. Now we're going to use an 1/8 inch solid carbide cutter instead of a 16th. So when we're on this general description tab, let's change this to an 1/8 inch. And we're going to need to change the product ID because this would be telling us what tool to actually order. So let's go to the website for Kennametal through the product link. Drag that over into the screen so you can see it. So this has pulled up the 16th end mill we're using. We want an 1/8 inch. So let's scroll down to our options here, and we want the shank diameter to be the same if possible. So what we're looking for is dimension 1 is the size of the cutter and dimension 2 is the size of the shank. So what are our options? We have D1 at 1/16, 5, and here's 1/8 inch. Now there are two different options here for that size. Actually, it looks like three. And that has to do with how much cutting depth, length of cut we have. So that would be this length here. So let's look at what our options are here. We have an 1/8 by 1/8 with a 1/4 inch length of cut. And here we have 1/2 inch and 5/8. So what that's going to do is you can cut thicker and thicker material, but the rigidity of the cutter is going to be less. So I'm going to go middle of the road here, and let's pick on the 1/2 inch flute length, which is 4 times the diameter of that particular cutter, which should be a good proportion. So we're going to select that tool, and we're going to use the order number and flip back to Fusion, put in our order number, and in this product link tab we're going to wipe that out, and we'll go back to the Kennametal site, and we're going to put in the URL for that particular cutter. We're going to copy and paste that. You can hit Control C on your keyboard, and then Control V in the product length, and that way we can return to that 1/8 inch end mill. Now we need to go to the cutter tab and set the actual sizes. Just because we change the description to 1/8 inch doesn't make it an 1/8 inch. So we're going to set our diameter at 1/8 of an inch. And then our flute length, that was a 1/2 inch. And then our body length, 2.5. Our shaft diameter is 1/8 of an inch. And how much projection do we want out of the holder? And let's set our shoulder length and our body length as being the same. So graphically we have this 1/8 inch end mill. There really isn't a shoulder and shaft and shoulder diameter difference on this cutter. It's 3 flute, carbide, no coolant through. On our shaft, we got 1/8 inch. This lower diameter we need to change to an 1/8 inch as well. Then we go to our holder. We'll just leave the holder at default. And feeds and speeds. Okay, so to set our feeds and speeds, we go back to Kennametal's website. Now, unfortunately for this series of end mills, which is called the Go mill for general purpose, they don't list it in with the tables here. Unfortunately, they used to. And so what we have to do is we have to go back up to their catalog information. And where I found that was under Resources, Metalworking. And you go to the inch bookshelf and to the master catalog for rotating tools. Okay, so before we know the end mill we chose was a multi-purpose tool, so it can be used for a variety of different materials. So we need to look up the material chart and see how those are designated. So in the main page, we go to Material Overview, which is pages Y210 through 211. And we need to look up the material that we're cutting. Okay, so this same cutter, it could cut groupings P, M, N, and possibly S. But the materials we're cutting for this part is it's a bronze, which would be under copper and brass, zinc-based and machinable index. So this is this here, N4, and the green stands for non-ferrous. So pretty much those numbers can be used for non-ferrous materials such as aluminum, nylon, and plastics. Okay, so we'll go back to the index page, and now that we know we need a N or green colored reference on our chart, we're going to go to solid end mills. Okay, and it was a general purpose series, and that takes us to that section of the catalog, and our end mill we selected was a 3 flute, so we'll select on that. And we're going to see all the same general information we had on the order page, sizes and such. And we're going to keep going until we see page Q18 and 19, which is going to give us our feeds and speeds for the series end mill we're using. So they have a chart for short, long, and extra long. And if you remember, we picked a medium size flute length. So we used there were 4 sizes available, and we used the second size up. So we're going to use the regular chart here. If you were to go with the longer flute length for long and extra long, you'd use this one. Let's zoom into this. And we have our fractional sizes across the top. So this is general. It doesn't have to be exact on that. If you had a size that was in between, you would choose one in between. And the information we're most interested in is the cutting speed in SFM and the inches per tooth, which is synonymous with chip load. Okay, and those 2 numbers are what we feed into Fusion for the feeds and speeds. Now we chose an end mill that can do 2 times its diameter, 2D, in depth. Alright, so we had an 1/8 inch end mill, and we're going to go down, we're cutting a green material, and it was N4, which is this row right here at the bottom. So we're going to use a surface foot per minute between 820 and 3,250. Now it's going to depend on the spindle speed of our machine. Chances are we're not going to be able to hit this surface footage. So let's start with 820, and we know we can go up to at least 3,000. So let's note that number, 820 surface feet per minute. And we're using an 1/8 inch end mill, and that is going to be a chip load, or inches per tooth, of 1,000th and 1/10. So 0.0011. Now let's go back to Fusion and let's put those numbers in. It's under feeds and speeds. Let's assume we're going to go 5,000 RPM, a little faster because this is a smaller cutter. Oops. 5,000 RPM. And our surface speed, remember, 820 with a chip feed per tooth 0.0011. Okay, so to achieve 820 feet per minute, we would have to be spinning that spindle at 25,000 RPM. That's not realistic. Our machines can't go that fast. So we're going to put in 5,000 here. And our resulting feed per minute is only going to be 163 feet per minute. So our resulting cutting feed rate out of that is 16 inches a minute, 16 and a half. So we're going to take that number, and you're going to go Control C, and we're going to copy that feed rate. And then on our ramp feed rate, we're going to use about half. So let's put in 8 inches a minute. So that's when it's plunging and first engaging the work. Okay, on Post Processor tab, this is very important. Put this in as Tool 17. So let's change that to 17. And if you wanted to add a comment, you could add it here. Okay. And the other options you can leave alone. We have automatic tool changers. It's a live tool because it's spinning, and we're not going to check brake control. Okay, we're done making our 1/8 inch end mill. We're going to select OK.